Good afternoon, students. Today in class 10th chemistry, we are going to discuss metals and non-metals. In the previous classes, we have discussed about the properties of metals, properties of non-metals, and how do metal reacts with different acid, bases, and solutions. Today, whatever the topics included in the syllabus for the current session, the one topic that is reactivity series is included. So we have to discuss about the reactivity series. Reactivity series is a arrangement of metals in a sequence. Arrangement of metals in a sequence having the decreasing reactivity. So in the here we will discuss list of metals arranged. This is reactivity series of metals. So here I would like to list of metals. List of metals arranged in the order of list of metals arranged in the order of their decreasing reactivity. Their decreasing reactivity. There are different metals, different kinds of metals, as you know, in the periodic table form. When you move from left to right, first alkaline metals, transition metals. These are the metals that are included in the periodic tables. So different metals have different reactivity. So according to the experiment, it is decided that which metal is most reactive and which metal is less reactive. So, and make a series that when you will go through the lesson metals and non-metals, in that lesson, when you will turn over the pages, you will get the series that is in the blackboard here. And it's my request to you that you have to learn this series. When you will be able to learn the series, then you can do the experiments that which metal can displaces the another metals, which metals can displaces other metals. So reactivity series, as here written in the blackboard, reactivity series is a list of metals that are arranged in the order of their decreasing reactivity. So first of all, you see that there is a potassium in the top. K is the symbol of potassium, and I have written this potassium. Sodium, Na is the symbol of sodium, and I have written it as the sodium. Then Ca is the symbol of calcium, so I have written here calcium. Mg is the symbol of magnesium, so we have written magnesium. Ammonium, Al, aluminium. You should know the symbol of each and every elements. Zn is the symbol of zinc, Rn is the symbol of iron, lead, Tb is the symbol of lead, H is the symbol of hydrogen, Cu is the symbol of copper, Hg is the symbol of mercury, Ag is the symbol of silver, and Au is the symbol of gold. So in this series, when you move from top to bottom, their reactivity decreases. Their reactivity decreases. So the upper side is most reactive metals. Upper side is most reactive metals, and down side is least reactive metals. Upper side is most reactive metals, and The downside is the less reactive metals. So here I have written that reactivity decreases. Reactivity decreases as we move from top to bottom. So in this case, you can say that upper side are the metals which are more reactive, and lower side is the metal which are less reactive. So upper is if the upper metal is most reactive than lower metals, so upper metal can displaces the lower metals. Upper metals can displaces the lower metals. As here sodium, as we consider here sodium and potassium. So potassium displaces sodium, sodium displaces calcium, calcium displaces magnesium, magnesium displaces aluminum, aluminum displaces zinc, zinc displaces iron, iron displaces lead, hydrogen, hydrogen displaces copper, copper displaces mercury, mercury displaces silver, and silver displaces gold. So upper side metals is most reactive and that kind displaces the metals which are least reactive and that are written in the down side. So this is the metals reactivity and this you should know that as with copper, I have taken two metals, Fe and I have taken another metals copper. So Fe in the series is upside and copper in the series is downside. So Fe is more reactive and copper is less reactive. So from the solution, iron can displaces copper. Iron can displaces copper and copper cannot displaces iron. Iron can displaces copper, but copper cannot displaces iron. Similarly, zinc and iron we have taken one is zinc and another is iron Fe. So zinc is most reactive and iron is less reactive. So zinc can displaces iron, but iron cannot displaces the zinc. So this is the series sodium. So this is the series potassium, sodium, calcium, magnesium, aluminum, zinc, iron, lead, hydrogen, copper, mercury, silver, and gold. This is the sequence of reactivity series, and this you will have to learn. If you are able to learn this series, you can search out that which metal can displace another metal and which metal cannot displace the another metal. And the next is the topic is how do metals and non-metals react? How do metals and non-metals react? How do metals and non-metals react? One is the metal and another one is the non-metal. And how do they react? We have to learn here. So take one example as there is sodium, hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, sodium, hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, and so on. So the atomic number of sodium is hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium. That is 11. Its atomic number is 11. So when we will do its configuration, so there is the sodium, there is atomic number 2, 8 and 1. 11 atomic number and there is electronic configuration of sodium is 2, 8 and 1. Then as you know that in the center there are Sodium metal. This is the nucleus of sodium metals. In the first ring there are two electrons, and in the second orbit there are one, two, three, four, five, six, seven, eight electrons are in the second orbit. This one is the first orbit. You can say K. Second orbit is L. Third orbit is M. Here is only one electron. This is the electronic configuration of sodium. In place of K, you can say 1. In place of L, you can say second. In place of M, you can say third. First, second, and third are orbit. You can say first, second, and third orbit, or you can say K, L, M, and orbit. So this is the sodium. And when the sodium lost one electron, sodium lost one electron, so it will convert it into sodium plus ions. And one electron is lost. This one electron is lost. So after losing one electron, the sodium will have only two and eight electron in the outermost shell, and that is the complete shell. So there is a tendency of these metals to lose electrons. Alkali metals and alkaline earth metals, they have the tendency to lose one or two electrons and convert into sodium plus ions, because there are 11 electrons and 11 protons. 11 electrons and 11 protons. So 11, in place of 11 electrons, there are only 10 electrons, and one extra positive charge is there. So that is converted into sodium plus ions and one electrons. Similarly, the Cl, that we know chlorine, and its atomic number is 17, so its electronic configuration will be 2, 8, and 7. So when we will form, this is nucleus of chlorine, and in the first orbit there are two electrons, and in the second orbit there are 1, 2, 3, 4, 5, 6, 7, 8 electrons, and in the third orbit there are 1, 2, 3, 4, 5, 6, 7 electrons. So in the outermost shell there is a one electron. So it has the tendency to lose one electron, require less energy, and it can lose electrons. It is easy for the sodium to lose this one electron and convert it into Na plus ions. Similarly, in the chlorine there are seven electrons in the outermost shell. In the chlorine atom, there is seven electrons in the outermost orbit. So it is not possible to lose seven electrons, but it has the tendency to get one more electrons to complete its octet. So this get one electron and converted into chloride ions. Chloride ions, and its electronic configuration will be 2, 8, and 8 after getting 1 electrons. 7. So here is 17 electrons and 17 protons this size. But after getting, there will be 18 electrons and 17 protons. 18 electrons, 8 and 2, 10, and 8, 18. 18 electrons and 17 protons. So one surplus electron is here, so that will be upon the negative charges. So I would like to say that sodium is a metal. Sodium is a metal atom. This one is the metal atom, and this one is the sodium ion. This one is the chlorine atom, chlorine atom and it is converted into chloride ions. Now, sodium ions have positive charge and chloride ions have negative charge. So, there is a strong force of attraction between sodium ions and chloride ions. So, we can say here that sodium one electron extra here is, and in case of chlorine, there is 1, 2, 3, 4, 5, 6, 7 electron. So, this one electron will take sodium, it has positive charge and it will have negative charge. And there is a strong force of attraction there will be, and the formation of sodium chloride is taking place. So, how do metal and non-metals react? So, this is the process that metals and non-metals react. This is the process that metals and non-metals are react. Similarly, in the case of magnesium, similarly, in the case of magnesium, similarly in the case of MgCl2, there is Mg is the metal atom and its electronic configuration is 12. Its electronic configuration is 12. So its electronic configuration will be 2 8 to R 8 to 10 and to 12. So it is very easy for the magnesium to lose these two electrons. So it will convert into Mg2 plus 2 electron after losing 2 electrons. Its electronic configuration, this is the magnesium atom. And in the first there are 2 electrons and in the second there are 8 electrons. 1, 2, 3, 4, 5, 6, 7, 8 electrons, and in the third cell there is only 2 electrons. So it can lose this electron and it can lose this electron, and after losing this electron, there is only 2 and 8 electrons having complete octet. Similarly, in case of chlorine, as you have seen earlier, 17 electronic configuration to 8 and 17 atomic number. Chlorine has 17 atomic number and its electronic configuration is 2, 8 and 7. So this will get one electron and converted into Cl minus ions, chloride ions. This is magnesium ion, this is magnesium ion, and this is chloride ions. Chloride ions. Magnesium has plus 2 charges and chlorine has minus 1 charges. This is positive ions and this is negative ions. Similarly, in case of chlorine, this is chlorine atom. In the first cell, there is 2 electrons. In the second cell, there are 1, 2, 3, 4, 5, 6, 7, 8 electrons. And in the third cell, there are 1, 2, 3, 4, 5, 6, 7 electrons are there in the chlorine. So 77 electrons are there. So it has the need of 1 electron to complete its octet. So when it is taken 1 electron, its octet will be completed, and there is 2, 8 and 8 electrons. And its octet is also completed 8, 2 and 8 electrons. So metals has tendency to lose electrons and non-metals has tendency to gain electrons. Now this is magnesium and here is 2 electrons that extra have there. It wants to lose these 2 electrons to complete this this these electrons, and chlorine have only 7 electrons. So 7 electrons and it required one electron, it also required one electrons, and Mg wants to lose two electrons. So it loses this one electrons, and it loses this one electrons. So it has also eight electrons, and it has also eight electrons, and it has also eight electrons. And in this way, there will be the formation of MgCl2 in case. So metals and non-metals are reacting like this. Metals and non-metals are reacting like this. Now, now we will go through the properties of metals and non-metals. Properties of properties of ionic compound. Properties of ionic compound. I have here NaCl MgCl2. These are the ionic compound I have discussed just now. So properties of ionic compound. So first property is they are hard and solid. They are hard and solid. The reason is due to strong strong force of attraction. Due to strong force of attraction positive between positive and negative charges. So they are hard and solids. Second property is the brittleness is they are break into pieces when force is applied. They can break into pieces when force is applied. Break into pieces when force is applied. And third is melting point and boiling point. Melting point and boiling point is very high due to strong force of attraction. Due to strong force of attraction, considerable considerable amount of energy is required to melt or to boil. Considerable amount of energy is required to melt or boil. The fourth property is the solubility. So these ionic compounds are soluble in water and insoluble in solvent like kerosene and petrol. The fourth one is conduction of electricity. Fifth one is conduction of electricity. So the ionic compounds, as you know that ionic compounds are solid, and in solid state ions are not free to move So, in solid state, they cannot conduct electricity, but in molten or solution form, they are able to conduct electricity. So, as you know, the students today we have finished the lesson metals and non-metals. Only these topics are included in the syllabus of metals and non-metals. Tomorrow we will discuss the next topic of chemistry that is included in the syllabus. So these are the properties of ionic compounds. These ionic compounds are formed by give and take of electrons, and there is positive and negative ions meet together to form to form ionic compounds. So there is a strong force of attraction is there. So they are hard and solid. They are hard and solid due to strong force of attraction between positive and negative charges. Second one is brittle. Brittle means when we apply force, when we apply pressure, when we apply force or when we apply pressure on the ionic compounds, they break into pieces. And the when melting point and boiling point is another property is very high they possess very high melting point and very high boiling point. The reason is so for there is strong force of attraction and they require a considerable amount of energy to to boil or to melt. Solubility, in case of solubility, they are soluble in water but unable to solve in kerosene and petroleum. Similarly, in conductance of electricity, because they are ionic compounds, and when they are compounds in the solid states, their ions, their electrons are not free to move, so they are not able to conduct electricity. But when they are in the soluble state or they are in the molten state, they can conduct electricity because the ions are free to move and can carry the charges from one place to another places. So for today this is the end of this lesson metals and non-metals. I hope that from the book, whatever the questions are given in the in text questions and in the last exercise questions, what are the questions are asked in the previous examinations from books. You will have to learn them, you will have to practice them, how to solve the questions in the examinations. Thank you for today. Thank you.